All right, let's dive into a question that sounds super simple, but the answer, well, it stretches from the inside of your brain all the way back to the beginning of time itself. Here it is. Why can't you remember tomorrow?
I mean, really think about it. You can remember what you ate for breakfast yesterday, no problem, but you have absolutely no clue what you're going to eat for breakfast next week. It's like your memory works perfectly in one direction, the past, but hits a total brick wall when it looks the other way. So what's the deal? What invisible barrier is stopping your mind from peeking even 1 second into the future?
Now, you might be thinking the answer is in psychology or maybe biology, just how our brains are wired. But the real reason is so much bigger than that. It's actually a fundamental law of the entire universe. And our personal experience of time is just one of its side effects.
So, to crack this case, we're going to have to put on our detective hats. We're going to follow a trail of clues left behind by some of the most brilliant minds of the last century and a half. It's a detective story that's going to take us from old-school steam engines all the way to the Big Bang.
Okay, our first major clue is this single, incredibly powerful concept. It's one of the most fundamental ideas in all of science, and it's called entropy.
So what is entropy? Well, in a nutshell, it's just the measure of messiness. And the second law of thermodynamics is basically a cosmic rule that says the total amount of mess in the universe can only ever go up. It can never, ever go down. Just think about your bedroom. It gets messy all on its own, right? But it never, ever spontaneously cleans itself. The entire universe works exactly the same way.
And here's the amazing part. This one simple rule, that things always get messier, is the absolute key to understanding why our minds are locked to the past.
Okay, so here's the big connection scientists made. They realized that this constant, unstoppable increase in messiness, in entropy, is what gives time its forward direction. It's the reason time feels like a one-way street.
Let's follow the trail our scientific detectives left for us. First up, back in 1865, a guy named Rudolf Clausius gave this messiness a name, entropy. Then, Ludwig Boltzmann proved it was all just a game of probability. I mean, there are just way more ways for things to be messy than to be neat. Decades later, Sir Arthur Eddington gave it that perfect nickname, the arrow of time. But the final, mind-blowing connection came from Stephen Hawking. He's the one who said our personal psychological arrow of time, the way we remember, is directly caused by this physical thermodynamic arrow.
And look, this law isn't just some friendly suggestion. It is absolute. As Sir Arthur Eddington famously said, you can argue with pretty much any other theory in physics, but if your idea goes against the second law, you've got no hope. It is rock solid. Everything in the universe has to play by this rule, and that includes our brains.
And this brings us right to Hawking's brilliant insight. See, making a memory isn't just some abstract thing that happens. It's a physical process. Your brain cells have to do actual work. They burn energy, and when they do, they release a tiny bit of heat. And that little puff of heat increases the total entropy, the total messiness of the universe. Every single memory you've ever made has made the cosmos just a little bit more chaotic.
Okay, that's a really cool theory, right? But is that all it is? A theory? Or is there a smoking gun? Is there any real, tangible, measurable proof that creating a piece of information actually has a physical cost, that it creates real heat and disorder?
Oh yeah, the answer is a big, resounding yes. And this is where our detective story gets really good, because we've reached the climax, the actual experiment that proved it all.
So the theory part came first, from a physicist named Rolf Landauer back in 1961. He basically said that information isn't just an idea floating in the ether, it's physical. And he figured that if you erase a single bit of information, like flipping a 1 to a 0 on a computer, you must release a tiny, predictable amount of heat. It's a physical cost.
Now, for decades, that was just an idea on paper. But then, in 2012, scientists designed this absolutely incredible experiment to finally test it. They used a laser to trap a single tiny glass bead. You can think of it like a light switch. If the bead was on the left side, it was a 1. If it was on the right, it was a 0. Then, they erased that information by nudging the bead back to the center, and they used incredibly sensitive instruments to measure the heat that was given off.
And they found it? I mean, the amount of energy was ridiculously small, about 3/1000ths of a trillionth of a joule. But it was there, it was real, and it was almost exactly what Landauer had predicted all those years ago. This was it, the smoking gun. The physical link between information and entropy was proved.
Okay, so we've got the how. We know memory is physically tied to entropy, but that just opens up an even bigger, deeper question, right? Why? Why did the universe start on this one-way path in the first place?
The answer seems to lie in the very first moment of everything, the Big Bang. Now, why it happened this way is still a huge mystery, but we know that our universe began in a state of incredibly low entropy. It was unbelievably simple and orderly. And from that very first instant, the second law kicked in, and the universe has been getting more disordered, more messy, and more complex ever since.
So here's a cool way to think about it. The universe is on a one-way trip from a super orderly past to a chaotic future. And a memory? A memory is just a physical trace, a little footprint left on the part of the road that's already been traveled. You can't remember the future because the universe hasn't made that mess yet. There's no footprint there for you to see. So you might be wondering, could we ever go back? Could we reverse this? Well, funny enough, a 2019 experiment actually managed to briefly reverse the arrow of time for a single quantum particle. But, and this is a huge but, for anything complex, like a person, the odds of all our trillions and trillions of particles deciding to spontaneously go backwards into a more orderly state, it's so unlikely that it's basically impossible. For all of us, we're locked on this path.
So let's bring all this cosmic stuff back down to Earth, back down to you, right here, right now. What does this huge, universal law actually mean for the simple act of remembering a friend's face or your favorite song?
Well, it means that every single time you remember something, you're doing a lot more than just thinking a thought. You're actually interacting with a real physical trace, a tiny piece of preserved order that you've carved out against the constant, overwhelming flow of universal disorder. That simple memory of what you had for breakfast.
It's a tiny marker, a little footprint that's been left behind on the universe's grand, one-way march from perfect order towards total chaos. And that leaves us with one last, kind of beautiful thought to chew on. If making a memory is a real, physical act that costs the entire universe a tiny, irretrievable piece of its original order, it really makes you wonder, doesn't it? What then is truly worth remembering?